Okay, good evening. This is Professor David J. De Los Reyes. Okay, my topic for this morning will be a continuation of my subject matter, trigonometry. And this is now lesson number 30, and the title of the topic will be Example Problem on the cosine of sum and difference of two angles. Okay, let's proceed. The last time around, we derived the two more identities needed in the study of trigonometry, that is the cosine of the sum and difference. So for this morning, we'll be bringing out example problems on how to apply those two identities. Okay, let's try to bring out example number one. Oh, this is a practical application because if you don't have your calculator, and you're familiar with the cosine expansion of the sum and difference, actually you could take the value of the cosine of any angle. As long as you know the value of the so-called special angles without using the so-called trigonometric table or calculator. Okay, example number one. Find the cosine of 120 degrees. Cosine of 120 degrees, it's an angle greater than 90. And an angle greater than 90, if we try to take the cosine, it should be a negative value. Okay, let's try to bring out the figure of 120 degrees. For example, number one, this is the required angle. With respect to the 0 degree and measured clockwise, this is 120 degrees. And we are asked to find the value of the cosine of this angle here, cosine. Okay, let's now try to check the sine of the cosine of an angle that falls under quadrant number 2. The proper sign should be cosine is actually adjacent over hypotenuse. If an angle falls under quadrant number 2, the horizontal component is negative. The vertical component is upward. So if we try to take the sine of the cosine, cosine is adjacent, okay, over hypotenuse. So it should be a minus over a plus. And this is a minus. So supposed to be, if we try to take the cosine of 120 degrees, it should be a cosine value. Okay, let's try to bring out the solution. Oh, this is just the figure by using the expansion of the cosine of a sum. Okay, so for the solution, I will try to bring out first two right triangles. The first right triangle is a 30 degree, because 30 degree right triangle is actually a special triangle in which the sine of 30 is actually 1/2, so this should be 1. The hypotenuse should be 2. For the sine of 30 degrees to be 1/2. The adjacent side will be the square root of 2 minus the square root of 1, then take the square root of that will be square root of 3. Okay. We needed these values in the computation of the value of 30 degrees, whether sine, cosine, or other functions. For the second right triangle, luckily it was just simply a vertical line, 90 degree. Okay? If it originally it's a horizontal line, but if we try to rotate this one here, okay, then it stops at 90 degrees. The resulting right triangle will just be simply a straight line moving upward. And here, we could determine also the value of the sine of this 90 degrees, cosine of 90 degrees based on the figure. Okay, let's try to bring out expansion. Cosine of 120, 120 can be written as the sum of a 90 degrees plus 30 degrees. So actually it seems we are taking the expansion of the cosine of two angles. And according to the last discussion, lesson number 29, it should be cosine, cosine, sine, sine. If this is plus, this should be minus. Okay, that's expansion. That's the one we derived the last time around. Cosine, cosine. So this is sine, sine. If this is plus, this should be minus for cosine. Okay. So if we try to expand this, should be the cosine of the first angle 90 degrees times the cosine of the second angle 30 degrees. Because 90 plus 30 is actually 120, right? Well, we could represent 120 as the sum of two angles, which is 90 degrees and 30 degrees. 90 degrees is a special angle. We don't need any calculator in the computation of the triangle values, even with 30 degrees. That's why we represent 120 as a sum of the two special angles. So this should be cosine 90, cosine 30 minus sine of 90, sine of 30 degrees. From these right triangles, we could now take the specified values of this expansion. What's cosine of 90? Cosine of 90 will be no adjacent side. Adjacent side is actually equal to 0. Right? The hypotenuse is 1. So a 0 over 1 is actually cosine. Right? Is it cosine? Cosine. Okay? So a 0 over 1, this will be 0. So if the angle is 90 degrees, cosine of 90 degrees, this should be equal to 0. Right? So this is 0. From this. No horizontal component. It's just a plain vertical component. So it should be 0 over 1. Or a cosine of a 90 degree angle is actually 0. So this is 0. How about the cosine of 30 degrees? Cosine of 30 degrees, it should be adjacent over hypotenuse. So this should be square root of 3 over 2. Minus, by following this. Sine of 90 degrees. For sine of 90 degrees, it will be, there's a vertical component. Okay, and luckily, this vertical component is same as the opposite side in the hypotenuse. So if we try to take the sine of 90 degrees, this should be 1 over 1, or this should be equal to 1. So sine of 90 degrees is equal to 1. There's a vertical component, and this vertical component is at the same time equal to the opposite side, okay, in the hypotenuse. So 1 over 1 will be 1. So sine of 90 degrees will be 1. So this will be 1. Okay? At least you know how to compute for the value of sine and cosine. If there is no horizontal component, cosine will be 0. If there is a vertical component, okay, sine will be 1. So this is 1. Sine of 90 degrees is 1. And sine of 30 degrees, it's the hand for the 30 degrees. The sine of 30 will be 1 over 2. This is times 1. Okay? A 0 times square root of 3 over 2 will be 0. Any number multiplied, or a 0 multiplied by any number will be 0. And 1 times 1/2 will be negative 0.5. So cosine of 120 will be 0 minus 0.5, or cosine of 120 degrees is negative 0.5. It should have a negative value because we verify it here, right? The cosine of 120 degrees should have a negative value, and that value is negative 0.5. And if we try to check the validity of our answer, for the calculator, I call this just punch 120. Okay? Because if we are using our calculator, we are not thinking. We are just only punching and we are bringing out the answer. But the computation of this calculator inside will be this. Right? And cosine, it's a negative 0.5. Okay? So don't always use your calculator. We just use our calculator to check our answer because the solution of the calculator inside is what we are doing. So the cosine of 120 degrees will be negative 0.5 by using the expansion cosine of the sum of two angles. Example number 2. Find the cosine of 150 degrees. Okay. I brought out two right triangles and unluckily the first right triangle is just a plain horizontal line. 180 degrees, right? And the second one is the same as the 30 degrees, right? It's this. So this is sine of 30 will be 1 over 2. This should be squared root of 3. We needed these values here, okay? Because after the expansion, we will be getting some values from 180 and 30. And if we try to bring out the solution, cosine of 150, 150 can be written as the difference. That's why our topic for tonight is sum and difference. Okay, the cosine of open quantity 180 minus 30 degrees closed quantity. 180 minus 30 is actually 150 degrees. And if we try to take the expansion of this, it falls under cosine of the difference, right? A cosine plus sine. So this should be cosine 180, cosine 30. If this is minus for cosine, this should be plus. Sine of 180, sine of 30. We all know these values now by going back to these right triangles. Cosine of 180, this is negative now. Cosine of 180 is negative. The adjacent side, okay, and the hypotenuse are the same. Cosine of 180 degrees. Okay. At this instant, the adjacent side and hypotenuse are the same, right? So the sign should be, what do you call this, a minus 1, minus all over a plus. Okay, a minus over a plus should be a minus. Okay, so cosine of 180 should have a negative value, and that value is actually negative 1. Right? So at least we now know where we got this negative 1. It emanates from here. I just plot the graph 180 degrees. Okay, and this is to the left, so this is a minus. Okay, so a minus over a plus will be a minus. So this is minus 1. Cosine of 30 will be square root of 3 over 2. Adjacent over hypotenuse. This is square root of 3 over 2. Plus sine of 180. What will be the sine of 180? For the sine of 180, there is no vertical component, right? Okay, so sine of 180 will be 0. There's no, so you try to correlate sine with the vertical component and for the cosine for the horizontal component. Since 180 got no vertical component, of course, sine of 180 will be 0. Right? And what is sine of 30 degrees? It is, this is 30, it should be 1, this 2, so this is times 1 half. Right? Minus 1 times the square root of 3 over 2. Square root of 3 is 1.732 divided by 2, that will be 0.866. Times negative 1, that will be negative 0.866. A 0 times 1 half will be 0. And negative 0.866 plus 0, it will just be simply negative 0.866. Therefore, the cosine of 150 degrees will be negative 0.866. Okay? It is this. This is 150 degrees, right? If we try to take the sine, cosine will be adjacent, okay, over hypotenuse. A negative over a positive, okay, cosine. This should be a negative. So for cosine of 150 degrees, as you check, the sign should be negative. And it come out from the expansion, it is negative 0.866. So this will be the cosine of 150 degrees. We verified the sign of the answer from here. Then from our expansion, it really came out as negative 0.866. And again, if we try to check the validity of our answer, just punch 150. Don't always use your calculator. This is just for checking. Because what the calculator is doing inside is what we are doing here. Take the cosine. This is negative 0.866. Okay? So this is correct. And so with the first one, it is negative 0.5. Okay, that's it, guys. That's the way how to apply the concept of the cosine of the sum and difference. Okay, this is Professor David J. De Los Reyes. Good morning from Los Angeles.